Hey guys, today's lesson is on equivalent fractions and comparing fractions word problems. This is also going to serve as a review of finding equivalent fractions and comparing fractions. So we're going to start with a review of comparing fractions, and first we're going to talk about the method of finding a common denominator. Now we know the denominator is the number on the bottom of a fraction, and when we find a common denominator, we want to make that number the same. There are two different ways that we're going to look at doing this. The first is by listing the multiples. So let's say I have the fractions 4/7 and 3/5. And I want to know if 4/7 is less than, equal to, or greater than 3/5. I can find a common denominator by listing the multiples of 5 and 7 and seeing which one they have in common. My multiples of 7 are 7, 14, 21, 28, 35, 42, 49, 56, 63, and I can probably stop there. My multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now I want to look at the list for a common multiple. They have a common multiple of 35. So I want to make my denominator 35. So I need to look at how I can get here by multiplying or dividing. So to get from 5 to 35, I have to multiply by 7. If I do it to the denominator, I also have to do it to the numerator. So 3 times 7 is 21. So 21 over 35 is an equivalent fraction to 3 over 5. On the other side, to get from 7 to 35, I have to multiply by 5. What I do to the denominator, I must do to the numerator. Now, because the denominators are the same, I can just look at the numerator to tell me which fraction is greater. So I have 20 over 35 and 21 over 35. I know that 21 is greater than 20. And that means that 3/5 is greater than 4/7 because 21 over 35 is greater than 20 over 35. Now I'm going to look at finding a common denominator by multiplying by the opposite denominator. So I have 3/4 and 4/6, and I want to know if 3/4 is less than, equal to, or greater than 4/6. What I'm going to do is I'm going to find a common denominator by multiplying by the opposite denominator. So for 3/4, the other or opposite denominator is 6. So I'm going to multiply by 6 on the top and on the bottom. For 4/6, the opposite denominator is 4. So on this side, I'll be multiplying by 4. And what I end up with is 18 over 24 and 16 over 24. Now the denominators are the same. I found a common denominator, and I can go ahead and compare my fractions. I know that 18 is greater than 16. So 18 24ths is greater than 16 24ths, which means that 3/4 is greater than 4/6. Now we're going to look at a method called the butterfly method. And we call it the butterfly method because we're going to draw a diagram that kind of looks like a butterfly. So we're going to compare the fractions 5/7 and 2/3. And I want to know if 5/7 is less than, equal to, or greater than 2/3. I'm going to start out by drawing the wings of my butterfly. And you can see that in doing this, I've grouped the numbers 7 and 2 and 5 and 3. I'm going to draw some antennae and a body for my butterfly as well. Now, when I use the butterfly method, I'm going to multiply the numbers that are in the same oval. So 7 and 2 are grouped together, so I'm going to multiply 7 times 2, which gives me 14. I'm also going to multiply 3 times 5, which gives me 15. Now I can simply look at those two numbers to decide which fraction is going to be bigger. Well, I know that 15 is greater than 14, so 5/7 is greater than 2/3. If I wanted to find a common denominator for these fractions, I could just multiply 7 times 3 and gives me a common denominator of 21. So when I compare 15 and 14, I'm really comparing 15 over 21 and 14 over 21. My answer will still be the same. Now we're going to review how to tell if two fractions are equivalent. This just means equal or the same. There are a couple different ways I can do this. The first one would be to find a common denominator, or to use the butterfly method. So I'm going to draw my wings. And I multiply in the same group. So 8 times 3 is 24. 6 times 4 is 24. And 24 and 24 are the same. So I know that 4/8 and 3/6 are equivalent fractions. The next way to do it is a little bit more simple, and I can do that when I can get from one number to the other by multiplying or dividing. So let's say I have 3/5 and 9/15. I know that I can multiply from 5 to 15 by multiplying by 3. If I can do the same thing on the top, then I know that those are equivalent fractions. 3 times 3 equals 9. So this one checks out as well. In this next example, 3/4 and 5/8, I can multiply 4 by 2 to get 8. But if I multiply by 2 on the top, 3 times 2 does not give me 5. So I know that these two fractions are not equivalent. Now let's get into the nitty-gritty of some example problems. The first example problem says Davion and Jacob are reading the same book for Battle of the Books. Davion has read more of the book than Jacob. Jacob has read 3/5 of the book. Which fraction of the book could Davion have read? So this question is giving me a comparison of Davion and Jacob. It tells me that Davion has read more of the book than Jacob, but it doesn't tell me exactly how much Davion read. So I need to find out which fraction of the book Davion has read. And I know that Davion's fraction is going to have to be greater than Jacob's fraction of 3/5. So I'm looking for a fraction that's greater than 3/5. So I need to look at each of these options and decide if they are greater than 3/5. The first one we can look at is 1/2. So let's compare 1/2 and 3/5 to find out if 1/2 is greater than 3/5. I'm going to use the butterfly. Five times 1 is 5. 2 times 3 is 6. Well, I know that 6 is greater than 5, so 5 can't be greater than 6. So 1/2 cannot be the solution. Next, we're going to take a look at 6/8 to find out if 6/8 might be greater than 3/5. And we'll use the butterfly again. 5 times 6 is 30. 8 times 3 is 24. And I know that 30 is greater than 24. So that one checks out. So I know that 6/8 is a fraction of the book Davion could have read. The next question says, Amari, Joel, Thomas, and Caitlin are each trying to run a mile for the presidential fitness test in PE class. Amari ran 5/7 of a mile before stopping. Joel ran 4/5 of a mile before stopping. Thomas ran 2/3 of a mile before stopping. And Caitlin ran 4/6 of a mile before stopping. Who ran the farthest before stopping? So let's look at what the question is asking us to do. The question wants us to determine who ran the farthest before stopping. Well, the word farthest tells me that I'm looking for the greatest distance. So what I'm actually looking for is the greatest fraction out of 5/7, 4/5, 2/3, and 4/6 of a mile. So I need to compare each of these in order to eliminate the ones that are less. So first, let's look at 5/7 and 4/5. I'm going to compare them using the butterfly method. 5 times 5 is 25. 7 times 4 is 28. Which means that 4/5 is larger. So since 4/5 is greater than 5/7, 5/7 can't be the answer. Now let's compare 4/5 to 2/3. And for this one, I'm going to find a common denominator. So I'm going to use the opposite denominator strategy. So for 4/5, I'll multiply by 3. And for 2/3, I'll multiply by 5. So I get 12 over 15 and 10 over 15. Well, 12/15 is greater than 10/15, which means that 4/5 is the greater fraction. So since 2/3 is less than 4/5, I know that 2/3 can't be the answer either. And lastly, I'm going to compare 4/5 and 4/6. This one I don't necessarily have to do any math for because the numerators are the same. The greater fraction is going to be the fraction with the smallest denominator because those pieces will be larger. So 4/5 has the smallest denominator, so 4/5 is greater than 4/6. If I look back in the problem at the 4/5 fraction, Joel is the one who ran 4/5. So Joel ran the furthest distance. The next question says Michael bought a piece of candy for 10 cents. What fraction of a dollar is 10 cents? We haven't learned about decimals yet, but we do know that 10 cents is a dime. And that's a good hint for this question. I know that 10 cents is a dime, and I know it takes 10 dimes to make a dollar. So what fraction of a dollar? So what fraction of the 10 dimes is 10 cents? So 10 cents is 1 dime of the 10 dimes I would need to make a dollar. So the answer here is going to be 1/10. The next question says, there are 16 cookies. If Jalen and his 7 friends each eat 1 cookie, what fraction of the cookies get eaten? So let's start by setting up our fraction. I know that the denominator needs to be 16 because there were 16 total cookies. But let's look at the numerator. I might be tempted to choose 7 over 16 because the denominator is the same, but I need to look closely at what the numerator will be. The question tells me that Jalen and his 7 friends each eat 1 cookie. So if I have Jalen and 7 of his friends, that's actually 8 cookies that get eaten. So the fraction I'm looking at is 8/16. 8 cookies and 7 cookies are not the same, so I can rule out the answer 7/16. Now if I look at the answer choices, 8/16 is not an option. So what I would have to do here is find an equivalent fraction. So let's see if 8/16 and 3/4 are the same. I know that I can multiply 4 by 4 to get 16. But 3 times 4 doesn't give me 8. So 3/4 is not equivalent to 8/16. Now let's look and see if 8/16 is equal to 1/2. And this time I'm going to use the butterfly method. I know that 2 times 8 is 16, and 16 times 1 is also 16. Since 16 and 16 are equal, I know that 8/16 and 1/2 are equal. So 1/2 of the cookies were eaten.